Good. First step first. We have to plug it in. Can anyone tell us where is this going?
One.
Perfect. Can anyone tell us where this is going from the right of 0? Remember the graph, and you will remember where this is going.
Positive infinity.
Correct. Again, an unfriendly situation. Good. Step 1. Y equals 1 plus, oops, sorry, sine 3x raised to 1 over x. Good. Then we apply natural log. 1 over x, natural log of 1 plus 3x. Now we apply the limit. So limit of natural log y, as x approaches 0 from the right, equals limit, as x approaches 0 from the right, from natural log 1 plus 3x over x. Where is the numerator going?
Zero.
Yes, because it's natural log 1, which is 0. Where is the denominator going?
Sure.
Excellent. Brilliant. We don't even have to manipulate. We don't have to do anything. Can anyone differentiate the top for us? And anyone differentiate the denominator for us?
One over 1 plus 3x times 3.
Excellent. Can anyone differentiate the denominator for us?
One.
Perfect.
I have
Okay.
a question.
Yes?
So at the very top in the orange, why did you plug in infinity instead of 0? Yeah.
1 over 0 approaches infinity. I did not plug in infinity.
Okay.
1 over 0 approaches infinity. The graph of 1 over x is this. As x approaches 0 from the right, the function values go to infinity.
Okay.
Perfect. Can anyone give us the answer? And only now I can drop the limit operator because I'm applying it. What is the answer?
3.
Excellent. Now we copy the beginning and the end. Now we swap the operators. What should I have in here so that the natural log of this is 3? Or you solve the equation.
E to the power of 3.
Excellent. That's it. Done. It needs a little bit of practice, but once you follow the steps, you should have no difficulties with this. Any questions? Any questions? Okay, the last section, and we'll come back to more examples for sure. 4 hours next week, definitely. The last section here is optimization. For that, this 8 for that 7 then. Okay, optimization. It's another application, of course, of differentiation rules, very similar to related rates. Similar. Optimization means find max min. That's all it means. Here we were not finding max min. We were finding the rate of change of such and such function. But here we are finding max min. Please remember, I saw it in your notes, in your homework solutions. I don't want you to say, Okay, I got at x equals 1, I got f of 1 is 5, and at x equals 3, I got f of 3 equals 10. This is the minimum, and this is the maximum. No, this is not what I'm looking for. In this class, we learned that these values are given by the sign of the first derivative, followed by the function values. If you do not present the reason using calculus, please, I want to give full credit, always. Just saying, oh, this is small and this is big. Oh, but if a 3-year-old can do that. We learned in calculus that the max min depend on the critical numbers and depend on the signs of the first derivative. If it changes sign like this, it's a maximum. If it changes the opposite way, it's a minimum. I don't want to see just as if we have not discussed this, right? Everyone can say, yeah, 5 is minimum, 10 is maximum, done, I'm moving on. No, if you do not present the calculus reasoning, like we did in every step of the way in class, please, it doesn't tell me that you understood the mechanism. It only tells me that you remember from algebra and from common sense that this is minimum and this is maximum. This is not what I'm looking for. So in order to find max min, we have to employ this table, not the second derivative unless you want to, but this is what we need to do. So we're going to look at applications. They're going to ask us to find max min. We have to justify using calculus why and how we got a max or a min. Okay, so the floor is open. I don't have much to say, just to follow steps. And they're going to ask us to find max min for different functions. Optimization problems. Okay, so based on what we studied so far, we should have no difficulties, unless I'm logged out again. And okay, I'm not logged out. Okay, I would like to look at one problem with a box. It doesn't matter which box. I would like to look at a problem with something like find the dimensions of the rectangle of the largest area that can be inscribed in a circle of radius r. Some of them are extensive. Some of the problems are easier than others. Others are the top and bottom margins are such and such. What is whatever they're asking us to determine, the smallest area. A piece of wire. So we have so many to choose from. So many. But let's start with a simple one with a box. So let's choose a box situation, either volume or surface or whatever. If 1200 square centimeters of material is available to make a box with a square base, and an open, then you can choose the next one, and an open top, find the largest possible volume of the box. So we are given, so this is 19 in 4.7. So we have 1200 square feet, square centimeters of material is available to make a box with a square base. So I'm gonna present a box with a square base and an open top. Find the largest possible volume of the box. Max volume. So we're asked to find basically the dimensions of the box and the maximum volume of the box. Okay. So we have, it says one more time. So this is the surface area of material is available to make a box with a square base and an open top. So this is the surface area. I have to name dimensions here. I only see two dimensions, right? X, 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 because it says a square base. And let's say Y, or height, whichever you prefer, Y or age, doesn't matter, is the height of the box. And this is given to us as the surface area. How do I determine the surface area? Well, I have the base, and I have four sides that are the same. So I will have S equals the area of the base, which is, because it's a square, it's x squared, plus 4x times y, plus x times y, plus, and the other two, 4x times y. Oh, I said y, but I wrote h, fine. Okay. Now, they're asking us to find the maximum volume. Well, but I have to write the volume. What is the volume of a box? It's the area of the base times the height. So that will be x squared times h. Just to make sure you're not confused by this, I'm going to white out this y. Okay, there is no y in the problem. Okay, so then this is what I'm asked to maximize. Find the maximum volume. But we don't know in this class how to find the maximum or minimum of a function with two variables. That's okay, because I'm given the fact that x squared plus 4xh equals 1200. Of course, I have to try to get rid of one of the variables, and I'll try to get rid of h. Solving this equation for h and plugging it back in, then I have a function of one variable. So I'll subtract x squared and divide by 4x. So 4xh equals 1200 minus x squared, and now I divide by 4x to get h. So 1200 minus x squared over 4x. This is what I need in here. Now, once I have the function as one variable with one variable, I know how to handle it. I just studied how to find max, min for functions. I know how to handle it from that moment on. So then I have indeed a function of the variable x, and I have x squared times 1200 minus x squared over 4x. Yes, I will simplify, and I will get 1/4 in front, and I distribute x, negative x cubed plus 1200x. So before we even continue, let's analyze this again from the beginning. So we were given the surface area of the box. It has a square base, and the height is unknown, and the base is unknown. The length of the base is unknown. But I know that x squared plus 4 lateral surfaces, sides, is this, which is given to us as 1200 centimeters squared. I'm also asked to find the volume, actually, or the maximum volume. I have to start by writing the equation that represents the volume of such a box, area of the base times the height. I realize that in this function, I have two variables. Not possible in this class. You have to wait till Calc 3. So, because it's not possible, of course, I was given a condition to make this disappear. And here's the condition. If I solve this for h, and I did, moving x squared, dividing by 4x, and plugging it back in, I finally got what I wanted. The x squared, 1200 minus x squared over 4x. I simplify a factor with a factor. So I have still to distribute x, negative x cubed and positive 1200x, and I have a 1/4 in front. I have the function. That's done. How do I find its maximum? And we know how. How do I find the maximum of any function? What do I have to do first?
Find the critical numbers.
Yes, thank you. So I have to find v prime of x. It's a polynomial. Leave the 1/4 outside. It's just impeding everything else if you put it in. So negative 3x squared plus 1200. In order to find critical numbers, remember v prime of x equals 0, or v prime of x is undefined. Well, that's not the case, because it's a polynomial function. So when I set it equal to 0, I will not even include this. This has to be 0. So negative 3x squared plus 1200 equals 0. Of course, I will divide both sides by negative 3. And then I have x squared minus 400 equals 0. We never divide by variables, but we can divide and simplify by a number that is not 0, of course. So then I have x squared equals 400. When I take square roots, I get x equals plus or minus 20. Not possible. Of course, only 20. And this is in centimeters. I cannot say, oh, this will give a maximum. No. No. Proof. X, v prime of x, v of x, 0. Of course, it cannot be infinity, but this is 20. Critical number is 0. Study the sign of this. I plug in 0, the sign is positive. I plug in 100, the sign will be negative. This is my proof that this is a maximum. Not if I plug it in and I get 1500, and if I plug in 19, I get something else. No, no. This is what we learned in calculus. That we have the derivative, we found critical numbers, we study the sign of the derivative, and now I plug in 20 in v of x, and this will be guaranteed because of the sign change of the derivative around the critical number. So this is guaranteed to be maximum. This is all I need you to show. So now in order to find this, I have to find v of 20. And of course, I also have to find the height so that I have all the information. So where was my v? Oh, the top. Okay, so in this function, I have to plug in 20. I'm going to put it in the graphing calculator. I have it ready. Here it is, y equals 0.25 in front. Oh, sorry. Yeah, it doesn't need parentheses, 0.25, because I didn't put it as a fraction form. Negative 3x squared, and then plus 1200. Nope. No, no, no. 0.25. I was copying from something else. Negative x cubed plus 1200x. And close. This is the function. Yes? Yes, it is. So now we plug in 20. And we got 4,000. And I also want to determine age. What was age? Age was 1200 minus 400 because it's 20 squared. And then I divide by 4 times 20, which is 80. Okay, yeah, I didn't need to do that. It's 10. Good. So age is 10. And this is 4,000. And I have to write the measurement unit and its volume. So it has to be centimeter cubes, centimeter cube. And this is, or cubic centimeters, and that is 4,000. So this was an easy situation, a good warm-up, right? So I was given the surface area. I was given information about the box. And I was asked to find which dimensions create the maximum volume and which is the maximum volume. I wrote the formula for the volume of the box. I realized that this has to go away. I have to have only one variable, but I was given the exact information that I needed to solve for age, plug it in. And then from this moment on, it was a piece of cake because this is what we've been doing in chapter 3. Of course, 4. It goes so fast that I don't even remember which chapter we're in. So chapter 4, of course. So we have this. We know how to find the maximum of a function. We found the derivative. We know that critical numbers come from two sources. In this case, this is not possible. From here, we got plus or minus, not possible because we are talking about the distance. So x is the length of this side of the base. And I don't know what this gives. Maybe it gives a minimum. I don't know. I have to study the sign of the first derivative to the left and to the right and see the sign change. Because it changes from positive to negative, this must be maximum. So I determined also the height, 10 centimeters. The base is 20. And the maximum volume, 4,000 cubic centimeters. Any questions?